Now let's see the secondary memory. It is nothing but a disk. You can consider it as a disk. Generally what they do is, in one disk, once we know about it, later they are going to place one disk above the other, and they are going to call it as a cylinder of disks. Okay, we can extend this concept to that as well. First let's see the basic here. So we are going to divide the entire disk, which is nothing but one surface of the disk, into various these concentric circles. They are also called as concentric circles, which are called tracks. So if you see them, all the tracks are concentric, which means they are all having the same center. Okay, and now after dividing it into tracks, we are going to divide it into sectors, right? So what is a sector is, this one is a sector, this one is a sector, this one is a sector, and this one is a sector. And generally almost all the hard disks are going to have 512 bytes sector size as 512 bytes. This is the standard that we are using, and based on this we will be having some other standards, like what is the page size. Page size is going to be 512 bytes, right? Now this is the smallest unit of data that we generally transfer between hard disk and other units like main memory. Okay, so you can consider it as if it is the smallest unit we generally transfer. Okay, now what are the various things that we need to know is, one thing is, even though the size of the how to find out the total capacity of the hard disk is, or one disk is, how many sectors there are how many tracks are there, and in a track how many sectors are there, which means sectors per track, and what is the size of sector in blocks, which are in bytes, which means number of bytes per sector. Are you getting this? The total capacity of the disk is going to be how many tracks we have in it, multiplied with how many sectors are there per track. Now you are going to get all the sectors which are present there, and how many bytes is present in each sector. Now what do you get? You are going to get the total capacity of the hard disk in terms of bytes, right? And now, even though the size is going to be something, we might not be able to use it to the full capacity, because we might have to leave some space for formatting. So that is called as intersector gap, something like that. Now some of the space is going to be wasted for formatting. Why is formatting required is, we might want to sometimes save what is the sector number, what is the track number, and whether it is full or whether it is empty, or is it free to be used. So we want to save some information. You can assume it as if it is some header. So header which is going to describe the entire sector. So for that reason some of this space is going to be wasted for formatting. And now if they say that for every sector some space is going to be wasted for formatting, you have to find out the total space wasted for formatting, and from the total capacity, if you remove that formatting space, then you can see how much usable data can be stored on that, right? Okay. And then in order to read or write data, we are going to have something called as a read-write head. Okay, so a read-write head will generally be present at some point, and in order to read or write some data, you have to move it from one track to other track, right? So the time taken to move the read-write head from one track to other track is called as seek time. Okay, and after you move to the required track, then the time taken for you to wait for the required sector to come under this read-write track, that is called as rotational delay. So how we do it is, we generally move the read-write head onto a particular track, and once we reach the track, we are going to stand there and we let the disk rotate. Now whenever it rotates, then the required sector is going to come under that particular read-write head. Got it? So the time taken for you to move the read-write head from one track to other track is called as seek time, and the time taken for you to wait for the required sector to come under the read-write head is going to be rotational delay, right? And after you get it, then you are going to start reading right from the beginning, right? Now how much time does it take for you to read the data or write the data? That depends on what is the speed at which the disk is rotating, right? Now if you know that the time taken for the entire rotation is, let us say, 10 seconds. I'm just giving you a rough figure. It is not in seconds, generally it will be nanoseconds or milliseconds. Now let us assume that time taken to rotate the entire disk is 10 seconds, which means if I leave the read-write head here then it will be able to read or write the entire track in 10 seconds, right? And if you know that there are 10 sectors on the track, then what does it mean? In order to read or write one sector, the time taken is going to be 1. Got it? Therefore, the access time for the hard disk is going to be, one is the seek time, other is the rotational delay, and the other is time taken to actually read or write the data. Got it? So you can write it this way: the average access time for a hard disk or hard disk is going to be, one is the time taken by the read write head to move on the on the disk in order to move to the corresponding track, plus the time spent by the read write head waiting for the sector to come under it, so which is nothing but the rotational latency or rotational delay, plus the time taken to actually transfer the data. That depends on how much data you wanted to transfer, right? Now for the entire track, time taken will be equal to the time taken for one rotation. Then for this much data, how much time? You can compute it that way. If these two are not given, you can assume that this one is 0. If it is not given, seek time, since it is very small, you can assume that this one is 0. If it is not given, you can assume that it is average. So average means, in best case you might land up at the beginning of a sector and you can start reading. In worst case, you might land up at the end of the sector and you have to go for one complete rotation. Therefore, an average you might have to wait for half the rotation time, isn't it? Half the time taken for rotation. So this one, if it is not given, go for half the rotation time, and if this one is not given, there is no other option, go for 0. And then this one, depending on the amount of data you are trying to read or write, you can find out that number. Got it? Okay.